Alright, moving on to our next section dealing with these circles. We're moving on to more about chords. So we're going to be looking at more stuff dealing with chords as we move along this section. So we have three or four theorems that we're going to be going over that are kind of the base of all these. So the first one is if the radius of a circle is perpendicular to the chord of a circle, then it bisects that chord. So if I have a circle and I draw a radius, okay, and then from that radius I draw another chord, okay, if I draw another chord, and that is perpendicular to that radius, then that chord has been bisected. So that chord will be cut in half of whatever the entire length is. So if the radius bisects a chord, it's going to take that chord and it's going to cut it into two separate equal segments. Okay. So if it's perpendicular, it will bisect that chord. And so if the radius of a circle bisects a chord that is not the diameter, then it is perpendicular to it. So if you have a circle and you have a line and a radius and a chord, and you know that that chord has been bisected, then it must also be perpendicular. So this is just the converse of the previous one. So it works both ways. If it is perpendicular, then it must be bisected. If it is bisected, then it must be perpendicular. So it's going both ways. Okay. Number 5, if the perpendicular bisector of a chord of a circle contains the center, the perpendicular bisector of any chord must contain the center of it. So what we would have here is that, let's say I have a circle and I have a chord that I've randomly drawn. Now, I am going to draw a perpendicular bisector. So I'm going to draw a line that's going to cut through it and bisect it into two equal parts, and also cut it so it's a bisector and it's perpendicular. So I know that that's 90 degrees. Somewhere along that green line has to contain the center of the circle. In other words, that green line is the diameter. Okay, so that green line must be the diameter of this circle. Okay, so now if I wanted to find the center, what I could do is I could draw another chord, take that perpendicular bisector, and I could find the center of the circle, because where those two diameters intersect is always going to be the center of your circle. Okay. All right, so let's say we have a circle. I have a radius of 5. I have this chord that's been perpendicularly bisected, and this half is 3. What is x? X has to be 3 because, again, it divides it perpendicularly. Okay. Let's say I have another one. Okay. And my radius is, in this case, let's just say 5 again. But now this entire length of this chord is, let's say the entire length of that chord is 7. What is y? Right, in this case, it would end up being 3.5 because it's going to be half of the entire length. So if the entire length is 7, it'd be half of it, which would be 3.5. Okay. So those are some theorems with chords and the radius dealing with perpendicular bisectors. Okay, so there's your homework, page 444, 1 through 12.